today we're going to be talking about week 2 of engineering math, and we're going to be going about two things that we did this week, which is separable and orthogonal trajectory. Now, separable, you're going to be able to tell based on the fact that you can separate, hence the name, your x's and your y's from each other. As you can see, the y can be factored out from back here, and then you have your x's and your y separate. So the first thing you're going to do is you're going to replace y prime with dy over dx. So we're left with 2 dy over dx equals, and just to make it simple, I'm going to factor out that y, and then we're left with this. So then step 2, we're going to want to separate variables. Okay, so then we're left with 2 dy. We're going to multiply by y, divide by y squared plus 5. And then we're left with, on this side, we're left with 1 over 4 plus x dx. Okay, so as we can see, now the third step is we're going to integrate. Okay, so to integrate both sides, you got to remember that natural log, the integral, of du over u is the natural log of u. Okay, so knowing this, we can then do this integral and see that the integral of this side is just going to be the natural log of y squared plus 5, and the integral of this side is going to be the natural log of 4 plus x plus c. You only need to do the c on one side. How do we get rid of natural log? We raise it to we raise e to whatever, e to the natural log of whatever, it gets canceled out. We have to keep in mind that there's a plus c here. It's not included into that natural log, so we have to do something to get rid of it. We can also rewrite this side like this, knowing power, the rule of powers, that if something is added in the power, you can actually multiply it together if the same base. So this, now we can end up rewriting our equation like this: y squared plus 5 equals 4 plus x times e to the c. E to some number is just a new number, so we can create it, we can write it as a new c. So then we're left with, and solve for y squared. We have y squared equals c 4 plus x minus 5. And that's all we got to do for separable. Now moving on to orthogonal trajectories. Orthogonal trajectories. We pretty much want to find the negative reciprocal of the differential equation. So given a solution such as this, you have to find the family of orthogonal trajectories. Now to do that, first you need to find the differential equation, which is covered in another video. Pretty much you take the derivative, 3y squared y prime equals 3cx squared. Solve for c. C equals y squared y prime over x squared. Just plug it back in. Y cubed equals y squared y prime x plus 4. The x cubed and the x squared cancel out. And you solve for y prime, you're left with y cubed minus 4 over y squared x. Okay, this is a differential equation. So for step 2, we want to replace y prime with negative 1 over y prime. Now, doing this, we're left with negative 1 over y prime equals y cubed minus 4 over y squared x. And now step 3 is just solve separable. Just like we did over here, you're going to do to this. So then we're left with negative dx over dy, because it's 1 over, equals y cubed minus 4 over y squared x. We separate these and we end up getting negative dx negative x dx equals y cubed over y dy minus 4 over y dy. Hope you guys can see that. And we integrate both sides. There's a negative right here. And then we just end up getting negative x squared over 2 plus c equals, the integral of y is just y squared over 2. The integral of this is just going to be plus 4 over y. And then that's it. Now normally they want you to solve for c, and so that would be step 4. Ooh, that was close. So step 4, solve for c. And now, knowing our previous equation, that just means I think it's c equals y squared over 2 plus 4 over y plus x squared over 2. And that's all you really got to do for that.